This is the note guide for thermochemistry. We'll be going through some definitions first and then talking about exothermic and endothermic processes in this set. First, let's cover some definitions. We have energy. Energy is the capacity to do work or supply heat. Within energy, we can break that down further into some other categories. First category we're going to look at is potential energy. This is stored energy. And an example of this stored energy would be water at the top of a waterfall. So an example would be water at the top of a waterfall. As the water falls, it can be used to drive a paddle wheel, so we can turn potential energy eventually into kinetic energy. Now, the type of potential energy we'll be talking about here is chemical potential energy, and this is the energy stored in chemical bonds. If you have ever lit a match, you have turned the chemical potential energy in the match head, the components that make up the match head, into heat or kinetic energy. Now, kinetic energy is the energy due to motion, and if you go on and take physics, one of the equations that you will use is that kinetic energy is a function of 1/2 mass times velocity squared. Now, this is also something that we use in AP chemistry, but you don't need to memorize it for this class. Heat is energy that transfers from one system to another, and we use temperature to measure it. So measured by temperature. What we're going to be studying in particular for the next few days is thermochemistry. And thermochemistry, if we take it apart, we have the word thermo in front. Think of a thermos, think of a thermometer. So it has to do with heat, and thermochemistry is the study of heat changes during chemical reactions and changes of state. So, for example, when something changes first from a solid, then to a liquid, and then finally through a gas, all of these changes take heat. We have to put heat in to change a solid from a liquid to a gas. Let's take a look at some more definitions. We're going to look at exothermic versus endothermic processes. And I want you to take a look at these two prefixes here. We have exo and we have endo. Exo, if you think of it, if you have an exit, if you have an exoskeleton, you have something that is going out. So if you have an exothermic process, then you have a process that is going to release heat. So exo means out. And then endo is inside, so it absorbs heat. So processes that absorb heat are endothermic. If they release heat, they're exothermic. Now, if we're looking at enthalpy, another definition, this is the heat content of a system. And specifically, it is the heat content of a system at constant pressure. Let me finish up the parentheses there. And let's underline some of these definitions so that you can see these are definitions that you need to fill out. Enthalpy is the heat content of a system, specifically at constant pressure. And we use the symbol H for it. So H, heat, it goes together. Now, we're not going to get picky at constant pressure, but H and heat and enthalpy are really only the same thing if they are at constant pressure. We're going to be looking at systems, and the system is the part of the universe that we are studying. So, for example, if we had a fire burning, let's draw little logs here, okay? So there's some logs, and they're burning. The part of the universe that we would be studying would be the wood that is burning. The surroundings is everything else in the universe. So this would include the air around the burning logs. It would include people that might be standing around the burning logs, enjoying the heat of the fire. So everything but the actual wood burning is the universe. Delta H is the heat change or enthalpy change of the system. Anytime you see a triangle in front of a variable such as H, it means change. So sometimes this is also called the delta H. And we're going to be looking at endothermic processes. This means heat flows into the system. And we're going to be looking at exothermic processes, which means heat flows out of the system. So let's do a couple of stick figures just for fun and look at exothermic and endothermic systems. So let's say we've got a skier. There's their little skis. And there's their arms. And they're happy because they're skiing. And we're going to give them a little beanie. Okay? So what we have here is a skier. And our system is the person. And we're going to say that it is 12 degrees Celsius out here. Okay, so it's a brisk day. So if this person is skiing and the temperature is colder than body temperature, this person is actually exothermic because the person is releasing heat to the air. Because remember, your typical body temperature is about 37 degrees Celsius. So the person's 37 degrees Celsius, they are transferring heat out to the air. So this is an exothermic system. Now, if you're transferring heat out into the air, you're actually losing heat. So you've got a negative delta H. You're losing heat. So exothermic systems have a negative delta H. Now let's take that same person, and now they're going to go over to into the ski lodge, and they're going to go sit in a sauna to warm up because they got chilled because they were outside where it's cold. So now they're sitting in a sauna, and they're happy because they're getting warm. And there's that pile of rocks they've got in saunas. All right. So we're still looking at the person. The person is our system. And they're in a nice warm sauna. So in this case, the person is picking up heat. So the person is endothermic. They're picking up heat from their surroundings. Now, since they're picking up heat from their surroundings, they're gaining heat. So it's actually a positive delta H. So an endothermic process has a positive delta H. Let's take a look at one more scientific example of an endo or exothermic process. We're going to take a look at ice cubes melting in water. So there's our glass, and we've gotten some ice water because it's a hot summer day. So we've got a few ice cubes floating around in here. So there's our ice cubes floating around in the water. So our system is going to be the ice cubes, and our surroundings is everything else. So in this case, we're going to have room temperature tap water on a summer day. So let's say that's 25 degrees C water in our glass. Our ice cubes are going to be starting off at 0 degrees C. So what's going to happen is that the ice cubes are going to melt. And as they melt, they're actually absorbing heat from the water. So ice cubes absorb heat to melt. Which means that we have a positive delta H because we're looking at the ice cubes. So we've got a positive delta H. It is an endothermic process. So even though the water is getting colder, the reason the water is getting colder is because it is transferring its heat to the ice cubes.